In example 1, we're going to evaluate the following geometric sequences. In part A, we want to know the value of the 18th term, and we're given a formula of a sub n is equal to 4 times 3 to the n power. We're also asked what is the common ratio. The common ratio is this number here, 3. It's the base that the exponent is raising. So we'll write here that the common ratio, or R, is 3. Let's figure out the 18th term. To figure out the 18th term, we're going to do the same thing we did with an arithmetic sequence, except this time n is in the exponent position, so we'll have to raise 3 to the 18th power, then multiply by 4. If you have a calculator handy, your calculator knows order of operations, and so you can just type that in. Looks like it's a very large number. 154968195 So a little over a billion there. Well, not a little over, a lot over a billion. And that'll be the 18th term in that sequence. Part B, a geometric sequence has a formula here, and we want to know what a sub 7 is. In this case, all we need to do is replace the n with 7. We'll use our calculator, -5 times 2 to the 7th power, and hit enter. We get -640. So the value of the 7th term, or a sub 7, is -640. In part C, we're going to evaluate a sub 4 is equal to 2 times 3 to the n power. A sub 4 is a shorthand for the value of the 4th term. To do this, all we need to do, same thing we did up here, with a new formula though, we'll just replace that n with a 4. So a sub 4 is equal to 2 times 3 to the 4th is 81. And then we'll do our multiplication following the order of operations and get 162 for that 4th term. In D, we have a geometric sequence that has a formula of a sub n is equal to 2 times 2 to the n. We want to know the position of the term with a value of, and you could do this for sure, but, well, maybe not for sure on this one. But anyway, I'm going to change this 10, and we're going to make that a 16. So I'm going to change the original problem. If we want to know the position, we have to find n, and we're going to substitute 16 in for a sub n. Here we can divide by 2. You can treat that like a coefficient, kind of, if you're used to doing that. So that's 1, then we have 2 to the n power. There's a way to solve this using a logarithm, but it's not necessary for what we're doing here. We just have to find a value of n that makes this true. Well, 8 is 2 to the 3rd power, so for this one n must be 3. Or in this case, the value of the 3rd term is 16, and we want to know that position, so we've got the 3rd.